Let's take a tour of radicals. We'll look at simplifying radicals or evaluating radicals using our calculators and just simplifying them, not necessarily evaluating them completely without using our calculators. Let's start with a very general tour. If I write the radical sign with a 4 underneath, this is asking you for the square root of 4. In other words, what number multiplied by itself twice gives you the number under the radical sign? Of course, the square root of 4 is 2. 2 times 2 is 4. But the square root of 4 could also be negative 2, because negative 2 times negative 2 is also positive 4. So which answer are we looking for? In some situations, we will want both the positive and the negative answer, but generally, and that's the case for this situation, this module, we're looking for the principal square root. So we're only looking for one answer, and the answer we're looking for is the positive answer. So when we say the square root of 4 is equal to 2, we're giving the principal square root, or you can think of it as the positive square root. All of this only makes sense if the number under the radical sign, the 4 in this case, is positive. We can move beyond square roots though. How do we know that the square root of 2 is actually what we're looking for here? Why is it the square root? Well, we can think of there being a little 2 here, but the same way that we ignore numbers in the denominator when they're ones, for example, we would never write 3 over 1 and just understand that to be 3 with a 1 in the denominator. If we just write the radical sign without a number, we're talking about the square root. As soon as we have a number there, we're in different territory. Here we're talking about the cubed root of 2. What number multiplied by itself 3 times gives me the number under the radical sign? Or the 4th root, or the 7th root. So we can talk about the nth root of a, where n can be any value, any positive value greater than 2. Here we'll look at all possible situations for the values of both n, so the order of the radical, as well as the values for a, the number under the radical sign, or we can call this the radicand. If the number under the radical sign, or the radicand, is greater than 0, it means it's a positive number, and n is even, so the order of the radical is even, the answer you'll give is always going to be positive. So for example, we said the square root of 9 will be a positive answer, in this case, positive 3. We could also say the 4th root. What is the 4th root of 16? N here, the order of the radical is even, and of course a, the number under the radical sign, the radicand, is positive. The answer will be positive, and what will it be? 2. Is 2 times itself 4 times is 16. What happens, however, when a is a number less than 0? So when a is negative, but n continues to be even. So for example, what is the square root of negative 4? There's no number I can think of that multiplied by itself twice gives me negative 4. And in fact, there are no real numbers for which this is true. So you could say not a real number. Once we move away from real numbers into the world of imaginary numbers, complex numbers, then we've got an answer for here. But there's no real number for which I can find, or that I can find as an answer. Similarly, the 4th root of negative 16 is a non-starter. There's no number multiplied by itself 4 times that'll be negative, and we would also write that this is not a real number. We're not going to dive into imaginary numbers at this time. Okay, so if a is again positive, the number under the radical is positive, and n is odd, so the order of the radical is an odd number, like 3 or 5 or 7, well then the outcome is going to be positive. For example, if we've got the cubed root of 27, that gives us the positive answer, 3. 3 times 3 is 9, and 9 times 3 is 27. The cubed root of 27 is 3. The answer is positive. Short note here, every square root has two answers, a positive and a negative. Every cubed root actually has three answers, and this is simply the principal cube root. What's odd about the cubed root is that there's no negative answer that's possible. The other two answers are imaginary numbers. So in the real number system, there is only one answer for a cubed root. Finally, what happens if the radicand, the number under the radical sign, is negative with an odd order? For example, the cubed root of negative 8. Well, if this was a 2 or a 4 or another even order, this is a non-starter and the answer would be not a real number. But because we're being asked to multiply a number by itself 3 times, this works out. And the cubed root of negative 8 is negative 2, because negative 2 times negative 2 times negative 2 works out to be negative 8. Negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. Anytime I'm multiplying a negative number by itself an even number of times, I end up with an even number. But if I multiply it by itself an odd number of times, I end up with an odd number. Let's see this in action. We're asked to evaluate the following. For some of these, we'll be able to do them without a calculator, and in other cases, we'll certainly have to reach for one. So make sure yours is handy. First question, what is the square root of 49? Well, 49 is a perfect square, which means it has an integer answer. The square root of 49 is 7. 7 times 7 is 49. Secondly, what's the fourth root of 256? Fourth roots get big awfully fast. It turns out the answer is 4. With a nice tidy answer like this, just the number 4, this is a great time to check that you know how to enter fourth roots into your calculator. Go ahead and give it a try. Next, the square root of negative 4. We're trying to take the square root, so an even order of a negative number. There's no answer to this that is a real number, so we're going to write not a real number as our answer. Now, what about the square root of 37? Unlike 49, 37 is not a perfect square. There are no two integers when multiplied together. Give me 37. So here you do have to reach for your calculator. Arbitrarily given to 2 decimal places, the answer is 6.08. Similarly, 65 does not have a fourth root that is a nice integer. It is not a perfect fourth. So now that you know how to put fourth roots into your calculator, you can try this one. You'll find the answer is 2.84. Similarly, 19. Now this one sometimes throws folks, but as soon as we see a negative and we're trying to take a square root of a negative number, we feel that this is not possible. But the negative is out here. The negative has nothing to do with the radical. So the answer is negative, whatever the square root of 19 is. The square root of 19 is 4.36, so negative 4.36 is our final answer. This bottom series looks promising. So the cubed root of 27, actually we tried this one, the cubed root of 27 is 3. Now we're looking at the fourth root of negative 49. Negative number, so the negative number as the radicand under the radical sign, but an even order, that's not going to work out. Not a real number is what we're left with. And finally, the cubed root of negative 27, we can take a cubed root of a negative number because it's an odd value. That works out. The answer is, in fact, negative 3. And finally, this lets us play around with more complicated radicals that aren't really as bad as they look. What is the square root of 10 squared? Well, you could think of it this way. That is the square root of 10 squared, so the square root of 100, and the square root of 100 is 10. But remember that when we're taking the square root, we have an order that is 2. So maybe I just realized that I'm trying to take the square root, the second order, or order of 2, of something that is itself squared. The answer is always going to be that number itself. Try that here. What is the square root of 5 to the power of 2? Well, if we play the same trick, the answer should just be 5. Is it? Well, 5 squared is 25. So what we're really being asked to do is take the square root of 25, and the square root of 25, yeah, that's 5. So as long as the order of the radical and the exponent to which the radicand is raised, the number under the radical, are the same, these are the same, not this guy, the answer is just the number under the radical sign without the exponent. So that's true if I raise the number under the radical sign, the radicand, to the exponent first and then try to take the square root, or if, like this, we take the square root of 10 and then raise it to the power of 2. You can think of that in a number of different ways. Let's see what we get. So this fundamentally means the square root of 10 times the square root of 10. And we know that we can pull radicals apart, so we can also put them back together. So I can write those 10s under the same radical sign. I can write that as the square root of 10 times 10. In other words, we're being asked for the square root of 100, and the square root of 100 is 10. So if we recognize that pattern elsewhere, we can skip right to that final answer. So here, the square root of 5 squared, that's just going to be 5. Try proving that to yourself. And of course, the nth root of 3, all raised to the power of n, is also 3. So we don't need to know what the order and the exponent are. They can be variables. In action, what is the square root of 3 squared? Of course, it's just 3. And similarly, the fifth root of negative 27, well, I don't know what the fifth root of negative 27 is, nor am I really interested in raising 27 or negative 27 to the power of 5 and then doing that calculation. But I recognize once again, as we did over here, that the order of the radical and the exponent are the same, so the answer is simply negative 27.